I'm hearing breathing, Bob.
All right, thank you.
Bob, one of the things that you'll be seeing is you'll see the trailed stars, but you'll actually see the asteroid is trailing as well, but in obviously a slightly different direction and a lot shorter. That's because of its change of rate of pace. Yeah? Does that make sense?
Yes, it does. That's very exciting that it's changing its speed relative to us that quickly. That's very interesting.
Which is why we should be tracking it in the same way that you track a satellite or the International Space Station. But unfortunately, there's a problem with the way the software is working on that, so we couldn't do that.
That's very cool. Very cool. This whole thing is very cool. And listen, if you do want to say something at any point, just do so. Interrupt me. Just say something. If you want to.
Okay, thank you.
Okay, we're going to start the show in 1 minute. 1 minute. 1 minute. Okay, we're going to start the show in 1 minute. That was me. Sorry.
Probably me as well.
Yeah, when I do my flick of the switch, it starts to... everything starts to work. Turns on everything.
Yeah.
Okay.
I am screen sharing Pat, the homepage, if you want it.
Okay.
And we got our first
looking
image
up.
in there as well.
Great. Okay, we'll start the show in about 30 seconds. Who's all at there? 30 seconds. The Slew Show will begin. Hi everyone, this is Patrick Palucci with Slew Space Camera. Thank you for joining us today. It is October 11th, Thursday, and we're here today to track Asteroid 2012 TC4, which was actually just discovered on October 4th. This particular asteroid is about 100 feet long, which is about close to a 10-story building, and it is only about 59,000 miles away, which is about 1/4 the lunar distance, so it's pretty close to us. And when Paul and I were talking about potentially covering it last night, we decided we need to do it given the fact of how close it was to Earth. And so we're excited to have this opportunity to do it. We're actually going to be tracking the asteroid live from the Canary Islands Observatory that's off the coast of West Africa. And we'll be using our facilities, which are be manned by Slew's own Paul Cox. Paul's imaging it right now. If you're on the slew.com homepage, you can channel surf and select the multiple feeds we have. We also have 2 feeds for you tonight that you can check out related to the asteroid, and we'll go through and explain what you're seeing. Also with us tonight is Bob Berman, Astronomy Magazine columnist, longtime Slew editor, and Slew friend, and author of many books. Bob, thanks for coming with us today, as always.
Pleasure, Pat. Great to be here. This is very exciting.
It sure is, Bob. And one of the things, Bob, that is, we've covered asteroids in the past, as anyone's known that comes to slew.com's site. We've been doing live shows, actually, believe it or not, for the last 30-plus days. And just a quick shout-out to Paul Cox, because he's headed up a program in promotion of the upcoming release of our iPad app. And we did about 30-plus days of live astronomy on Slew. And I tell you, when Paul first told me about that, I was a little like, how are you going to pull that one off? That's a lot of programming, a lot of work. But he did it, and Paul, congratulations on getting that done. It's an amazing feat. And I was thinking about that. Paul may have broken a Guinness Book of World Record. I don't recall ever reading about someone who's done 30+ days of live astronomy. But anyway, let's get back to the asteroid. Bob, some of the concerns I have with this one is that over the past 3 months or so, we've seen, now this is the third, I believe, object that's come into our solar system relatively close to Earth, this one particularly close to Earth, and we haven't been aware of it. Perhaps you can give us your thoughts of, should we be concerned, and what are we going to do about it? Because if this particular asteroid hit Earth, tell me if I'm wrong, it would be a Could it be an extinction event, or would it just be wiping out a city, or what would happen? Maybe you can start there as well.
Okay, yeah, it's very exciting, and you're right, a little scary because this one's very, very close. It's passing only 1/4 the distance to the moon, 59,000 miles, and tonight is the night. Over this evening, that is during the next 12 hours, it's whizzing past. SLU is doing very well to track it, to see it live, and since it's 100 feet across, that's about the size of a 10-story building, you bet it could do major damage, because coming in at the relative speed that it is, at about 4 miles a second, or 8 times faster than a bullet, it has enough mass to reach us at full cosmic velocity. And nope, it would not destroy Earth. This would not be one of those dinosaur-ending events, but it could not just destroy one city, but do a widespread destruction over an area perhaps 100 miles across if it hit us.
Right. Well, you know, back in June, if you guys recall, a story broke on LZ1 that basically SLU actually kind of broke with the help of Paul Cox, and Robert McNaught, who discovered this asteroid, came on the show. You know, he discovered it on June 11th. We tracked it on June 14th on its close approach. That was kind of the first time we said, whoa, that was kind of odd. Then back on September 13th, just last month, QG42 came into view, which was discovered on 8/26. We tracked it on 9/13. You know, and that was another one that was like, whoa, it's a second asteroid. Now we're at the third one here. This one's smaller, but this one's a lot closer than those other ones, as I recall. So that's
a lot closer.
Right. That's been kind of a little scary there. So right now, if you're on the SLU.com homepage, probably the best view is maybe the T2 high mag view that Paul Cox is providing us live feeds. Paul's going to jump on when he can. He's actually manually tracking this thing, and it's moving very fast. Bob, what's the? Did you write down the speed of this asteroid?
Yes, I did. And there are two ways to think of the speed. One is the actual space speed relative to Earth. Of course, we're going around the sun at almost 19 miles a second. It's going around the sun at a very similar speed. But how fast relative to us? That would depend upon whether it's coming straight at us, or it's sideways, or going away from us. It turns out that relative to us, it's 4 miles a second. That's relatively slow so far as cosmic speeds go. I mean, consider that the Perseid meteors that everybody enjoys every August 11th hit our atmosphere at about 37 miles a second. This one's only 4 miles a second, so relatively slow as such things go. But the other way of thinking of it is, how fast is it crossing the sky? In other words, what's its angular speed? And there the number 4 also comes in. It's moving at about 4 minutes of arc in every 1 minute of time. And to put that into perspective, the apparent size of Jupiter is almost 1 minute of arc. So this asteroid, Pat, moves 1 Jupiter width every 12 seconds.
Wow.
Picture that, moving a Jupiter width in 12 seconds, and you could see why Paul has to do this manually, because there's no automatic button that you can push and then have a giant telescope track something at this kind of speed. So we're doing very well to be imaging it at all. And one of the things, of course, in addition to the science and the people who are really into serious astronomy, I won't kid you, there are those who think that the government can lie to us and hide the fact that there is a very close object that might actually even hit us. And so we provide a service for those too. I won't say paranoid. Let's be kind and call them skeptical people, because we are showing them the actual object at its closest approach. You can actually see it right now moving through the stars of the constellation Capricornus at this breakneck speed. And so you can see for yourself as this night goes on that all is well, and it's not colliding with us, because it can't both be out there among the stars of Capricornus and here, one or the other. Right. So if it's out there, it means that it hasn't hit us, right?
Exactly. One of the things I want to let people know that on the SLU.com homepage, we do have a half-meter telescope currently in operation, and Paul originally was going to try to manually control that one as well to help us get a view of Neptune while the asteroid was going to zip by it. although we decided he needed to focus on the T2 feed. So the half meter is going to be running, I believe, standard missions that we'll see. I believe a galaxy had popped up earlier, and I don't know what's going to be in there right now, but we'll see maybe in a few minutes what it is. Also, I know you guys could be watching this potentially in Google Plus or YouTube, our YouTube channel, and some people like to post questions there. Unfortunately, we don't monitor those areas that closely. If you want to ask a question to Bob or myself or even Paul, please go to slooh.com. That's our homepage, slooh.com. Click the Slooh conversation box, and you can post in there using like your Facebook account or something like that, and then or Twitter account, and we'll try to answer your questions during the show if you have any. So Bob, looking at this asteroid and coming in, what are you? When we talked about the damage that this could do, I mean, 100 feet. Would this burn up in the? Wouldn't this burn up in the atmosphere? Because it didn't seem like it's
probably
that big.
not. Probably not, because we had one hit Chicago a few years ago, right over the suburbs of Chicago. That was only half the size. It broke up into giant pieces, one of which, by the way, came right through the window of a teenager's bedroom, and came to rest, just barely missed him, and came to rest breaking a mirror. Bringing bad luck to this person, although collecting a nice chunk of a asteroid is not bad luck, it's good luck. So this one is twice that size, much too big to be turned into dust. This one would survive its passage through the atmosphere. And remember, there's a difference between comets and asteroids. Comets are flimsy things made of ices. They rarely, if ever, survive their trip through the atmosphere at high speed. They do burn up and even turn just to water. In fact, there's a theory that we got our oceans because of these comets coming in, especially in the early solar system when this was more common. But not these asteroids. These are made of rocky, stony, metallic contents. They're sturdier stuff, hardier stuff, and they tend to survive their passage through the air. And so if it did hit us at 4 miles a second, well, impact or kinetic energy forces vary with the square of speed. So you're talking about 100 feet in diameter. Certainly you're talking about at least 30 or 40,000 tons hitting us twice as fast, I'm sorry, 8 times faster than a high-velocity rifle bullet. Not good.
Right.
Can I butt in, guys?
Yeah, go ahead, Paul.
Just to let people know what we're actually seeing here. The asteroid itself is the small, long line, trailing line, against the background stars, which are the long trailing lines. And we're seeing it trail because this thing is, because it's so close to Earth. It's like the other asteroid that we covered, 2005 YU-55. It is so close to Earth that its apparent speed as it moves across the sky, it's more like a satellite or the International Space Station going over, rather than a more distant object like the ones I covered at the weekends, which are just a dot. You know, they appear as a dot against the background stars.
Right.
And the other interesting thing that we covered at the weekend, when we showed this asteroid and 2 others, is one of the asteroids we looked at was classed as what's called a potentially hazardous asteroid. And that was 7 million miles away. And what I was trying to explain at the weekend when we were looking at these things is that here's this thing, right? And it's 59,000 miles away.
Yes.
And it is not classed as a potentially hazardous asteroid. And the biggest reason for that, the reason for it, is their size. The other one was well over 1 kilometer in diameter, whereas we've already said this one's, you know, it's actually far less than 100 feet. So that's the difference. Even though it's really, really close to us, it's not classed as a potentially hazardous asteroid, whereas the other one at the weekend was 7 million miles away, but it was classed as a potentially hazardous asteroid.
They seem like they're both hazardous, to me at least.
Yes, this is closer in size, perhaps a little bit smaller than the Tunguska event that occurred back in 1908, on the which was an event that knocked down all trees, total destruction for 50 miles in all directions. and that one blew up in the atmosphere. This would be more likely to penetrate all the way to the ground.
Wow, that's crazy. So you guys, if you are not familiar with SLU, all the program that we do live for the public, free on the homepage, is funded by membership. So please consider that on our homepage. We have different membership levels. Please consider it as part of the support of this free program. But the main part of membership is you get an opportunity to control these various scopes that Paul is controlling right now. So it's a unique opportunity to not only support a cause and provide this, because this type of programming reaches everyone in the world, believe it or not. We have a worldwide fan base who loves coming on these shows and learning a little bit more about space and seeing it live and in real time. That's what's unique about SLU. We have patented technology that brings these images to you in minutes, and it's a really cool program that's gives you an opportunity to control these scopes, snap your own pics, and of course interact with space enthusiasts worldwide. So it's a really fun group to be a part of. You're actually supporting something like the free programming we do. Also, we have our iPad app coming out, which I think is going to be really cool. It's going to take the SLU membership program to another level, and we hope that should be out by the end of probably first week of November. So, Bob, as we're looking now at the asteroid as it's zipping by, you know, I think I read that when we classify these things as near Earth or potentially hazardous, there were like 9,000 plus near Earth asteroids already identified zipping around the solar system. Does that sound about right? Am I right on that?
Yes, and this is why we've completely changed our thinking about interactions with other objects. There was a time when we really thought, we took the word space literally, that there's a lot of space, there's a lot of room up there, that Earth evolved independently, life had nothing to do with the rest of the universe. Now that we see that interactions are actually common, and Pat, you pointed out that just in the last month we've been bringing you very close asteroids that have been passing by. This one is really close at 59,000 miles, passing by tonight at its closest approach. And this just shows, sure, we do get hit from time to time. Sometimes it changes the evolution of Earth's biology, as it did 251 million years ago, and then again 65 million years ago, and it almost did just a little bit more than a century ago on June 30th, 1908. It can happen any time. And now we think that because these objects, comets certainly carry amino acids, these are the building blocks of life, that rather than life having to have evolved on Earth from scratch, we at least had the building blocks of life. And there are those who believe in panspermia, the idea that more than just building blocks, that they're actually primitive life forms, microbes, bacteria, viruses that may be hitching rides on some of these. We're going to know a lot more in 2014 when we will land on a comet, send a space probe that has been launched, the Rosetta mission launched in 2004, Pat, and it's going to rendezvous in May of 2014. It's going to map out the comet's nucleus in August and then land on it in November using instruments, spectrometers, to find out the exact mineralogical and chemical composition. Not sophisticated enough to look for actual viruses, but we're honing in on finding out what these things are really doing to Earth and how they play a role in Earth's history. As we look now at this asteroid moving so quickly, 4 miles a second as it's passing Earth, that it's traversing the apparent width of Jupiter every 12 seconds. That's how quickly it's zooming past us, at 1/4 the distance to the moon.
Now, if you guys are on the homepage, if you're looking through the half-meter telescope channel, I believe up there right now is the Cave Nebula. We're looking at live. That's just kind of a side treat that we're providing tonight. But if you go to the T2 feed, you will get the actual asteroid. And as Paul was explaining earlier, it's usually, you'll see it as a dot or a little smaller trailing dot as opposed to the trailing stars. That's the asteroid in motion that Paul is tracking manually. Paul's actually in the UK, and our robotic observatory is at a world-class site in the Canary Islands. And for those of you who don't know where that is, that's off the coast of the west coast of Africa. And Bob is actually with us tonight, and he's actually in upstate New York, and I'm out in Los Angeles in California. So we're all over the place, and we're tracking this live on SLU today. So Bob, what else can you tell us about asteroids, and what are the differences between like an asteroid and a comet, for instance? I mean, for those who don't know, what could you tell us about that?
Good question. Well, the bodies of the solar system, once you've eliminated the big ones, the sun, the planets and their satellites or moons, what you mostly have left are comets and asteroids. Comets start out as balls of ice, plain water ice. We say they're dirty ice because they have pebbles embedded in the ice and dust, fragments. So they're contaminated ice, but typically 15, 20, 30, 40 miles in diameter. They don't look like much until and unless they come close to the sun, and then the ices, you can't say melt because you can't turn into liquid in the vacuum of space. The ice sublimates, turns directly into a vapor, a gas, and that's what creates the beautiful million-mile-long trail, like the new comet that we think that early next year we'll have one called Pan-STARRS and an even better one, ISON, that should be nothing less than spectacular a year from now in November and early December of 2013, a year from now. Those are comets. They've created awe and fear and, of course, beauty through the centuries. Asteroids are a different story. You don't look up and see an asteroid. There's only one that's bright enough to be even seen by the naked eye without a telescope, and that's the asteroid Vesta. And even that one is just barely there. It's would really test your vision in the darkest rural sites. So asteroids are telescope objects, sometimes binocular objects, and they are chunks of rock. The largest series, we're talking about close to 700 miles in diameter. The smallest ones, well, here's one tonight, 100 feet in diameter. Thousands of them from a planet that never formed. Couldn't form because in the early solar system the mass of Jupiter was just too great, kept tugging at these objects tidally and did not let them coalesce into a new planet the way Earth and all the other planets were able to form. So that couldn't be more different. Let's sum it up. An asteroid is a hard, solid body, can be anywhere from a few feet to 700 miles across, made of rocks, stones, metals. Comet, ices. It's an icy, fragile object, perhaps 10, 20, 30 miles in diameter. And the big thing there, the big draw, is when the ice sublimates into vapor and the solar wind blows that vapor back into a million-mile-long tail. So a comet can be 1,000,000 miles in size, as we hope Comet ISON will be a year from now. An asteroid, forget about 1,000,000 miles. You're lucky, like the one we're looking at tonight, talking about just 100 feet across. So very different animals.
So Bob, I'm going to take some questions out of the SLU conversation box on the homepage of SLU. That's where we answer as many questions as we can before we get off. We have about 10 minutes left in the show tonight. Bob, one question from Space Bats. Do these asteroids all come from the asteroid belt? What causes them to change direction and head towards Earth?
Right. The asteroid belt originally was a very behaved area between Mars and Jupiter. But over time, asteroids hitting other asteroids gave them some extra motion that could be in different directions. And some of them that had extra motion got whipped around by Jupiter in particular, sometimes by Mars, and they were whipped into new orbits. And enough of them have changed their original orbits so that they're no longer relatively round orbits, but very eccentric paths, oval paths that take it from around the orbit of Mars to Jupiter, all the way in. Some of them go inward of Mercury. And of course, when you do that, you're going to be crossing Earth's path. And if they're crossing Earth's path the same plane, the same flat CD or DVD-like plane, then there's the potential for danger. This is very different from the comets, which also have a home. Most of them start out in the Kuiper belt, which begins at Neptune. Just past Neptune, there's a repository of thousands of these ice balls. And we think there's an even larger reservoir called the Oort cloud that surrounds the solar system. So some can come in from the Oort cloud, some from the Kuiper belt. Asteroids come from much closer by, closer to Mars than Neptune.
Is the orbit, I don't know if you know this or not, I did put an orbit diagram on the SLU homepage in the lower box below our panel. For those of you who want to see it, that's provided by JPL, NASA JPL. Someone's asking a question about the orbit. Is it decaying? I mean, I don't know if you know that, Bob, or not, but do these orbits decay over time?
No. They tend not to decay. What they can do is change from a gravitational interaction. Now, you can bet your life that this one, passing only 59,000 miles from this heavy planet called Earth, has its orbit changed. And if an orbit is changed in a particular way, there may even be a collision. But orbits are generally stable, and even if they change shape, the asteroids are not going to go anywhere. I'd like to point out that in the same direction as this asteroid is the planet Neptune tonight. They're very close to each other in the sky in the constellation of Capricornus, and that's very cool. The new comet that was discovered, the huge one we think that's going to be so bright next year, Comet Ison, happens to be in the general direction of Jupiter. It's just past Jupiter, a few constellations over. Jupiter is in Taurus. The new comet was discovered in Cancer, in the constellation of Cancer. In this case, this asteroid shares Neptune's constellation of Capricornus. So if you look towards Neptune tonight, the third most massive planet in the solar system, odd blue planet, discovered in 1846, a blue planet with the same rough axial tilt as Earth, with a day that's 16 hours long and 13 moons, of which one is the largest strange moon in the solar system because it orbits Neptune in the wrong direction. Every other major moon in the solar system goes well-behaved, goes counterclockwise as they circle their planet. This one is opposite it, the giant moon Triton. That's in the same direction as this asteroid tonight. So cool stuff is happening in the same part of the sky.
So we've got about 5 minutes left, guys, on this particular presentation of Asteroid 2012 TC4. One thing I want to point out is our schedule on the homepage of SLU. It's the best place to come to get the latest updates of when our next show is going to take place. As outlined in earlier in the show, we did a lot of live astronomy shows throughout the month. Probably 30, 40 shows, honestly. 41 shows, and an amazing stretch of good weather, and Paul headed up most of those shows. Bob and I jumped on a bunch of them, but regardless, it was a pretty amazing feat. And we will be doing more shows. We tend to update the schedule. You know, the sky is always changing. Things like this asteroid comes zipping in, or maybe, you know, right now Jupiter red spot, I should say. It looked like it split in two. The guys were checking that out. You know, we do shows on a lot of different stuff, so please always come back. But also, you can follow us on Twitter, Facebook, or G+, you know, whatever your preference is. And we do put out notices when those shows take place. So always keep up on the latest. I know Paul has got some great ambition for an Astronomy Day event on Saturday of next week, not this Saturday, but the following Saturday, where he's planning on doing quite a bit of programming during the day, which should be pretty interesting. But also, we'll do other shows as well, so always come back and check it out. But also, you know, last thing on membership, please consider it. It's how all this stuff gets funded. You know, this stuff costs significant funds on SLU, and it's all funded by the members of SLU. It's part of your membership fees actually go to this, and we do it as a goodwill to the world to enjoy, to check out things in space they probably wouldn't know anything about. And you know, that's what these asteroid shows are about. I think SLU's bringing a lot of awareness of what's going on in the night sky. Comets, asteroids, as Paul's shows outline, you know, there's a lot of things going on a nightly basis. So please take a look at that as well before we get off. Bob, we're down to our last 3 minutes. I want to thank you again for coming on. Bob has been with SLU for I guess you've been on long. I've been saying 5 years. It's like 8 years, I guess.
Right.
So
that's right.
Bob's been with us since the beginning, even before we even launched back in 2003, I guess it was.
Yes, and I'd
So,
like to add
Bob,
to what you said about what people can do with SLU. It's not just you're part of the kind of the organization, the club, the membership. You're helping making these live shows possible. You also get to control the telescopes, and this is so
right.
cool. With the membership, it means that a particular night, a particular time, you want the giant telescope to point to Jupiter or Saturn and look at the live images as they're happening in full color on your computer. Save the images and be able to tell your friends, I took that picture using a
Right.
giant telescope in the Canary Islands. That's part of it. That's included. No extra charge for you get that with your membership, and I think that's the
I like
best
it.
thing that SLU does. Yeah.
I agree. I agree. So, Bob, always thanks for coming on. I appreciate
Pleasure.
it. And Bob, we're looking forward to the total solar eclipse event we're going to be doing with Bob. He's going to be on site, guys, in Australia, broadcasting in, and it's going to be a spectacular show. I think it's going to be our best show ever, and we've done some really good ones over the years. Paul, again, thanks for helping us tonight with the observatory. I don't know if you have any last things that you want to add about your upcoming show. Please feel free to jump in as we count down to the next 30 seconds or so. Do you have anything
Well,
else to add, Paul?
this was going to be the last month of live astronomy show, so you guys have basically hijacked the very pinnacle of my achievement this month. So thank you.
Yes, I could tell Paul wasn't. You know, it's funny. He's like, I saw it still in the schedule. I wasn't sure if I should have taken it out or what, but it's not in there
No,
right
we
now.
got to. That's what makes us different. We can react to stuff like this within 24 hours. You know, a few years ago, we reacted in 4 hours. We had notification of an asteroid that was coming in. It was going to hit the desert in Sudan. We were one of 2 organizations. It was a SLU member who grabbed an image of that. You know, that's the kind of stuff that we can do, and we really have seen, you know, space is so dynamic, it's so changing, there's so much going on. It was really difficult to keep up with it over this month. You know, we certainly had no trouble filling the shows. So.
Yeah, it was surprising, I have to say, how much content interesting content can be produced with the space, with using just our facilities in the Canary Islands. So we want to expand it. So guys, think about that membership. We have about 30 seconds left. The show on the homepage will click over to our what we call our recap mode. This show, I think it just did it, so it's over officially on the homepage, or maybe that's an image coming
No,
in.
it's still there actually, Pat. I just wanted to point out that that is the last. Now it's gone. I was trying to point out that lovely galaxy image was actually a member's mission. That's somebody, one of the members controlling the telescope to look at those live images, live color images of the Triangulum galaxy.
That's great. If you missed this broadcast or you want to see the early parts of it, the replay will show up in about 5 minutes on the homepage. We'll leave it up where you can watch the beginning part of it. And I don't really have anything else to add, guys. If you have anything, Bob, I'll give you one last.
I would just say, you know, till next time, as you say, space is always coming up with something new, and who knows what will intercede between now and the ones that we have scheduled. You never know.
Exactly.
Hey, look at Jupiter.
Right,
that's beautiful.
That's a recap Jupiter, but yeah, it is a good looking.
Okay.
All right, guys. Well, have a good night for SLU Space Camera. This is Patrick Paolucci. Good night, guys.
Good night.
Excited to have this opportunity to do it. We're actually going to be tracking the asteroid live from the Canary Islands Observatory that's off the coast of West Africa, and we'll be using our facilities, which are be manned by SLU's own Paul Cox. Paul's imaging it right now. If you're on the SLU.com homepage, you can channel surf and select the multiple feeds we have. We also have 2 feeds for you tonight that you can check out related to the asteroid, and we'll go through and explain what you're seeing. Also with us tonight is Bob Berman, Astronomy Magazine columnist, longtime SLU editor, and SLU friend, and author of many books. Bob, thanks for coming with us today, as always.
Pleasure, Pat. Great to be here. This is very exciting.
Hey.
I am screen sharing, Pat, the homepage if you want it.
Okay.
And we got our first image in there as well.
Great. Okay, we'll start the show in about 30 seconds. Who's all at there? 30 seconds. The SLU show will begin.
station, but unfortunately there's a problem with the way the software is working on that, so we couldn't do that.
That's very cool. Very cool. This whole thing is very cool. And listen, if you do want to say something at any point, just do so. Interrupt me. Just say something. If you want to.
Okay. Thank you.
Okay, we're going to start the show in 1 minute. 1 minute. 1 minute. Okay, we're going to start the show in 1 minute. That was me. Sorry.
Probably me as well.
Yeah, when I do my flick of the switch, it starts to... everything starts to work. Turns on everything.
Yeah.
Okay. I'm hearing breathing, Bob.
All right, thank you.
Bob, one of the things that you'll be seeing is you'll see the trailed stars, but you'll actually see the asteroid is trailing as well, but in obviously a slightly different direction and a lot shorter. That's because of its change of rate of pace. Yeah? Does that make sense?
Yes, it does. That's very exciting that it's changing its speed relative to us that quickly. That's very interesting.
Which is why we should be tracking it in the same way that you track a satellite or the International Space.
Hi everyone, this is Patrick Palucci with Slew Space Camera. Thank you for joining us today. It is October 11th, Thursday, and we're here today to track Asteroid 2012 TC4, which was actually just discovered on October 4th. This particular asteroid is about 100 feet long, which is about close to a 10-story building, and it is only about 59,000 miles away, which is about 1/4 the lunar distance, so it's pretty close to us. And when Paul and I were talking about potentially covering it last night, we decided we need to do it given the fact of how close it was to Earth. And so